Okay, in this screencast, I'm going to attempt to test drive a set class. A set is a very simple data structure, kind of like an array, but it is even simpler. It has no order. It can only contain something, an element 1 or 0 times, and so forth. It has very basic constructs like adding and removing and things like that. Our rules here are that we're not going to use any external libraries or functions besides just make to make the underlying data structure that we use. So that's basically it. We need to start by thinking, what is the simplest possible thing that we could begin testing, right? So you might initially intuitively say, oh, I guess we could try to test the add method, then we can see if it contains what we added. We could test remove, that's something we could do. But go even simpler than that. What's even simpler? Oh, maybe size? True, size is simpler. Size has a return value anywhere from 0 to infinity. What's even simpler than that? What is a method that has a function that has a smaller possible return set? Let's just say a Boolean return value. The answer I'm looking for here is empty. That's like the simplest thing we can assert, and we can do it right at the time when we initialize the set, right? So we'll say it is empty, and let's see what our assertion should be. We want to say expect subject is empty to equal true, right? That's a really straightforward assertion, so let's go ahead and run that. And I think the first exception we're going to get here, error is going to be obvious. We say imported, not used set. Well, we haven't used it yet, but we will soon, so I'm going to ignore that. However, we have undefined subject, so we need to define that. So I'm going to say that the subject, actually make it a var subject, is a pointer to a set. And I'm just going to, in a before each, I'm going to set that, initialize that to some value. I will say subject equals, I'm going to do it a pointer to a new set, and then, cool, so this assertion should now work. And now we should get, okay, undefined set. That is undefined type set, basically. So let's say type set, and it's going to be built on a struct. That's enough functionality to continue. What's our next error? Okay, it has no field or method is empty. So let's go ahead and build that. That is exactly the error we wanted here. So let me say func s to my set is empty, if we're returning bool. And what is the simplest possible thing we can do here? Right, we have a test asserting that the empty set is going to be empty by returning true. So you might initially think, well, we can create some sort of very simple data structure to store something in. We can check the length. If it's 0, then we will return true. But what's even simpler? If you think about it for a second, we can just return true. Right? It's even simpler. So let's run that. And we're green. That passes. Awesome. So now let's go ahead and do this on some other sets. Let's say we have a context here where we'll say with one element. And so what that means is that in the before each, I'm going to add just one element. So I'll say subject.add, and add a 1. And then I'm going to assert, that it, I guess, is empty. Or sorry, no, it has one element. It has one element, not empty. And then the function here, what should that do? I should go ahead and subject is empty to equal false, right? Because it's not empty. And then I'll close this off. Cool. And then we go up here and copy this whole thing because this is actually almost entirely going to be repeated here. Oh, well, let me do this here. Clean it up a little. There we go. Oops. Great. Okay, so now we have, I want to say with 2 elements. Change around word. 2 elements. Cool. So this means I'm going to do subject.add 2 as well as 1. And everything else about these should be the same. So let me go ahead and make my assertion. Now, oh, there's no add function. Okay, great. So let me go ahead and just fix that. Function s set add takes an element. I'm going to make this an interface. It could be anything. I'm only using ints, but just out of principle, I really don't care. So cool. Let me go ahead and save that and rerun my test. That should get rid of the error that we just saw that there's no add method. Cool. Okay, so it has an element. So we're asking about it's, oh, we did the wrong thing. Okay, yes. That is why our expectation looked all kinds of wrong. It was like a memory address. Yes, try that again. Great. Okay, cool. So it expected true, but it got false. Sorry, it expected false, but got true in both of those cases, which is exactly what we would expect, right? So now we have to do something a little different than this. So what can we do to make it return false for these two cases, right? You might now think, oh, this is the time where we add some data, and then we can check the length, right? Except actually, no, there's something even simpler we can do. We don't need any kind of data store, because all we need to do is say that is empty is not false, right? So instead what we can do is we can go ahead and make a state here. We'll say is empty, and let's say that's a Boolean. And we want to basically have it be true at first, right? When you first create a new set, it is true. But the problem is that the zero value for a bool is false. So let's go ahead and just make a constructor that can do this for us. And I'll just say func new set. And its goal is to just return a pointer to a set. And it can just say return pointer to a set where is empty is true. And that should work just fine. And so we're going to have it start by being true. But then what will happen is that when you add things, we'll just say s.isEmpty equals false. Cool, so let me save this. Let me go back over here, and now we'll actually use the new set that we just made. So I'll say subject equals, let me just delete this, and let me just say, oops, new set. That should work. Let's try it. One moment here. Okay, let's make absolutely sure that I actually saved this. Oh, yes, I might have saved it, but I forgot to do one thing here. So isEmpty now has to use that, right? So let me go to true here, change this to, I want to do basically set.isEmpty, and that should work. Go over here and run that again. Cool, everything's green. So what's the next thing we can do here? Now we've got our isEmpty working for all three cases. We said the slightly more complicated thing that we can do, not the add, remove, contains, that's further on, but size is kind of intermediate, right? So let's go ahead and do size for these. Let's go ahead and say in our empty case, we expect subject.size to equal 0, right? Cool. So the error that we should get here is that, well, that's not the error that I wanted. What did I do on line 20? Oh, I see, I need to add another parenthesis. Okay. Cool. No field or method size is exactly what we expect. So size 0, let's do func s set size. This is going to return an int. And we want to get a 0 here, right? So what's the simplest possible thing we can do? Okay, the simplest possible thing is we can, oops, not remove, but return 0. Cool. Save that and again. And we should be all green. Great. Okay, so now let's come down here to our with one element example, and I'll say expect subject.size to equal 1. Right, and let me yank this down here, 43, and say I'm going to put some space in here. So size should equal 2, right? Yeah. And so now we should get two failures. One is where we basically expect 0 to be 1. The other is where we expect it to be true. So now how are we going to fix that, right? Now this is where you might think we really have to have a data store, right? You're going to tell me now we can have a data store, add, we'll put elements into it, we can check its length. But again, no, there's something even simpler we can do. So what is that? Let's think for a moment here. All we need to do is every time you add something in our test, you're going to increase the size, right? That's all you got to do. So we need a size first of all. So let's go up here to line 8, and let's go ahead and add a size method. So I'm going to, or a size value. So I'll say size, and that's going to be an int. It will start out as 0, which is exactly what we want. Every time we say add, we're going to do s.size plus like this, right? And then when you ask for the size, you can just do s.size, and that should work. Let's see if that does work. Waiting, and it does work, so we're all green again, right? But now that we have this size in here, we probably don't need to have is empty anymore, do we? Right? So if I go to line 4, I'm just going to get rid of this and delete inside curly braces, delete the is empty, return is empty. So now what I want to ask if you're empty is I want to just say s.size equals 0. Then you know you're empty, otherwise you're not, right? So now also is empty, doesn't need to be false anymore, I just don't need to use it at all. So let's rerun our test after I did that refactoring. So I've not changed the behavior at all, I've just changed the tests are still the same, I've just refactored here, okay? Cool, so now what can we do? What's the next step forward? How about we go ahead and do contains, right? That's obviously one step beyond. And empty, then size, then contains is good. So we've already got an add. So let's see if we have contains in here. So contains, a pretty simple check for that right here would be if I did expect subject dot contains anything in the 0 case is going to be 2 equal false. It's not going to contain anything, right? And then down here for my one element case, I can do expect subject dot contains 1. That's going to be true, obviously. But then subject dot contains 2 should be false. That should make sense. And then on 49, here we're adding 2 elements. So I'm going to make 3 assertions, I guess. I'm going to say subject dot contains 1. I want that to equal true. Then I want to say expect subject dot contains 2 to equal true. But then I need a false case too. It doesn't just contain everything in the world, it only contains some things. So I'm going to say contains 3, and oops, need a capital letter here, to equal false. Okay, does that make sense? I think it should. Let me go ahead and run this. And I think you can tell the exception we expect here. There's no contains method, we have not defined it. So let's go ahead and add that. Okay, func s set contained element interface. What's a Boolean result? Cool, so how can we do this? Our first test obviously would pass if we just returned false. We'll go ahead and skip that triviality then. So we need something to iterate through our set and see if we have this value, right? But we don't even have any kind of backing store or list of elements at all, right? We just have a size. So let's go up here to line 8 and let's add something. Let's say elements, and it's going to be an array of interfaces, so we can put anything in there. Again, I'm only using ints in my examples, but I could in theory add anything, and for the sake of the generality of this idea, I'm just going to use interface. So we have elements now. They start out empty, which makes perfect sense. But what I want is, I want to actually be able to assign a starting size. I think a size that might be good to be something like maybe 10. So let me save this and go over here and say that when you make a new element, you're going to go ahead and put a starting size of 10. I think that's a good initial capacity to kind of play with and experiment with our ideas. So we have that, and so we want to go ahead and say that the elements that we're going to use to back this set, to actually store things, is going to be, we're going to do a make, and it's going to be an array of interfaces. And I think you want to do this, and then I want to say the size, so it's going to be size, right? And then I think I need a comma here. And so if I do this, everything should be, potentially could work now because we have something to store the elements in. So let me go to the add method, and let me say that s.elements, I need an index to put this element into, right? So I think I'm going to have to use size, because if you start out and your size is 0, and you want to put your first element in, you know the index is also going to be 0 because these are 0 indexed slices. So it makes perfect sense to say s.size, and then I'm going to say that equals the element that you're trying to add. Now here I'm incrementing the size, so now it would be 1 after adding your first element, and so on. That makes perfect sense to me. So then now when we ask, do you contain something, we need to iterate. Basically we want to say for I equals 0, or initializing, while I is less than, what does it have to be less than? You want to go through every element. Say we look at our example of 10 elements, iterating 0 to 9, right? We want to check everything up to the element, I guess, that would be our actual size. Like for instance, if you had elements array of 10 items, you wouldn't want to index into the 10th index, right? It only goes from 0 to 9. So I think what we want to say is while this is less than s.size, and you can do I++, and then we want to go ahead and do our check and say if s.elements I equals the element that you're looking for, return true. That makes sense. And if you didn't find it, we'll just say, hey, return false. And that should be good. So now let's run our tests. We just made several changes there, so this is kind of a leap of faith. Oh, yeah. So, of course, there's a typo on line 526. Line 5, no, that cannot be right. Was it actually 5 over here? Oh, it was not in our test. It was in the actual set definition. So elements, make, interface, size. I'm going to have to see that error again because it didn't stick. What's wrong? I think I just spelled something. Oh, and interfere. That's right. I spelled it wrong. Right. Okay, so let me go over here. Interfere. Right. So let me change this word to interface. Cool. Run this again. Awesome. Cool. So now we've got some real functionality. Things are starting to kind of come together a bit here. So we've done this contains with all three types, the empty case, one element, and multiple elements. Now let's go ahead and do, what's the next thing we can do? We can add things, see if it contains. Probably remove is the next piece of functionality that we really need. So I'm going to come down here to line 53 where I have two elements in this, this set. And I'm going to go ahead and say subject.remove, and I want to remove the first thing to kind of get things out of order. So not just remove the very last, most recent thing, but the first thing. So I'm going to do that, and now what's that going to do to my expectations here, right? So I want to expect that subject.isEmpty. It still should equal false because it had two elements, now it's going to have one, so it's not empty. I want to expect that subject.size, that should equal 1. And then I want to expect that subject.contains 1, that is going to be, 2 equal false. And I want to say subject.contains 2 is still going to be true because we haven't removed that. And then we still do not have 3, although I don't really know that I need to test the case where we don't contain 3 anymore because why would I have added 3? That's kind of a weird case. So I think this is probably good enough. So let me go ahead and run this here. And of course, there's no field or method remove, so we need to add that now, right? So let's go ahead and say func. Oops. Remove. I probably could return like an error code or something, but I don't need that much sophistication here. It's a very simple test that I'm writing. So what I want to do here is I need to iterate through all my potential elements. So how can I do that, right? So it's very similar to the contains case, where I say I is initially 0, while I is less than s.size, I++, and then if s.elements I equals element. Okay, so let's just say I'm iterating through my underlying element slice. It's like an array. And I find the element. How am I going to remove it, right? Because you have to think here, if I had several elements, let's go ahead and map this out a little bit, right? If I had, say I had like 1, 2, 3, and then I have these empty, essentially they're just 0 positions that I haven't stored anything in yet. They're empty interfaces, but let's just pretend they're like nil. It's a simple idea. And if I go ahead and I remove, say, this 2, and that becomes a nil. And if I then decrement my size to be 2, I would no longer be getting this 3. If I tried to say contains 3, that would just not work, right? I could do this, and you would see that the test would obviously fail, but I'm going to save you the time and explain this. So what can we do to allow ourselves to remove something? I think the smartest strategy we can use is to simply move the last element of our array to that position to overwrite it, and then decrement our size, and that will be fine, right? So let me go ahead here and say, if we found it, then let us say s elements I equals s elements, and then I want the very last element, so I guess I would say s.size. Is that what I want? If you had, let's just say you had 3 elements, and the one you're looking for is like, say, the second of those two, and your element is 3, what you really want to get is, in that case, I guess the index would be size minus 1. So we're going to do that. And then one other important thing we need to do is if we, let me fix my typo here, elements, I equals s, elements s size minus 1 is cool. If we find it, we also say s dot size minus minus, right? And if we didn't find it, then we just didn't find it, and everything's fine. So cool. Let me save this, go back over here, and run again. Cool, everything passes. Great. Now at this stage, without changing any functionality, I want to just look at these two functions, contains and remove, and you're going to see that they actually have some duplication that we can refactor out, right? So they're both iterating in this I equals 0, I less than s dot size, I plus plus. So what is the common behavior there that we could potentially remove, right? Contains and remove, they both have an array. I would say what they're both basically asking for is, what is the index of the element that you're trying to find, right? So imagine we have an index method that's going to look very similar to this. So we'll say func s pointer to a set, and we say index, and we have an element interface. And let's just say that what it does is it says for I equals 0, I less than s dot size, I plus plus, and it's going to say if s dot elements I equals the element that I'm looking for, then I want to say return I, and that's essentially telling me the index. And if you did not find it, then I need to return something that says you didn't find it. So we could just say return -1. That would be cool, except now I need a data type here. So let's say that's an int, and oops, cool, right. So if you did this, how would things look here, right? First of all, I'm just going to make sure that after having added that everything still compiles, that I didn't make a typo or something in there that's invalid. That's a nice, cool, nice sanity check. Cool, so let's go ahead and see if we can do that with, let's try with the contains method here, right? So let's just say index equals s dot index, and we'll say L, and we'll say, yes, this did not actually need to be a method. I probably could have just removed this. Let me say delete to I. Right. Yeah, I can actually totally do that. So let me just say index equals, give me the index of L, and then what do I want to do here? No, I completely was wrong. I could not do that. I absolutely do need the, there we go. Yes, because I am saying s dot elements. Yeah, I was wrong. So anyway, so index equals s dot index L. Cool. So what I can say is that if the index, if it wasn't found, so if index equal -1, then I can just return, right? And I can return false, like I know it did not find it. But otherwise, I know that I want to, oh, I don't want to do anything. That's all I have to do now, right? So interesting. So what I could do even more simply here is I could just say, I could just delete to s, and I could just take this thing and let me see, how can I do this? Can I cut that out? Let me think here. Backspace. You know what? I'm not doing some Vim foo right now. I'm just going to do this very manually. So if s dot index element equal -1 and return false. Okay, cool. Let's see if that still passes. Awesome. No, it does not. Wait, missing return end of function. Set.go 29. What did I do? Oh yeah, I need to return that Boolean value. So go over here and I need to return this. Return false. Oh, I can return this. I can just say, right, so I don't even need to do this kind of if whatever business. So return if the index equal -1, and that means contains it. If it does not equal -1, that should work. Yes, it's kind of weird looking, but great, everything still passes, cool. So let me do the same thing to remove. What I want to do here is I want to say index equals s dot index of L. I want to say if index equals -1, and I'm just going to return, which is totally fine because I don't need any return value here. But if we did find an index, if the set does contain this element, then I want to say set dot, this is where I'm going to go ahead and do my logic like we just did here, where I move the last thing to that position. So when I say s elements, instead of I, I'll just say index, and then cool, that makes sense, and I decrement the size. So I think everything's still good. Let me move back over here and run that again. Awesome. So now I want to, how about we go ahead and prevent duplicates. So far you're actually able to like make duplicates here. So I can actually over here I can say that you can't make duplicates. So how would I do that? I think I want to say it prevents duplicates, and the way I can assert that is I will say my subject, I'll say add 1, and then I'll say subject add 1, and then I essentially can assert that expect subject dot size dot to equal, should still equal 1, right? And I'm pretty sure that right now if we run this, it will absolutely. I'm just going to focus on this one example here. It will absolutely fail. Yep, that is undefined. It has to be a capital E. Awesome. So it expected 2 to equal 1. So it actually has duplicates right here, right now. So what's the best way we could do that? Probably what we want to do in the add method is just say that, look, if this already contains the element you're looking to add, that we should just back out, right? So we'll say if s dot contains L, then just say return, just get out. Seems like a pretty simple way to do it. Awesome. Cool. So for our last exercise here, let's go ahead and see what we can do if right now we have an underlying store that gets us up to 10 elements. But what happens if we go beyond that, right? So let's just say I add it, I'm just going to say like, it grows when beyond capacity or something like this, right? Externally, I'm not sure really how we're going to test that. It's kind of transparent from the outside, but we can certainly make sure that it doesn't like blow up, right? So like right now, if I say, subject.add, let's just say 1, and then let me sort of, let me do this. 3, 4, 5, 6, 7, 8, 9, 10. Let's add an 11th element, and then I need to just change all these. So I don't know a fast way to do this. I'm not like a master of Vim, but I can just type manually here. 4. Oh, I see. So I want to change this to 5, change this to 6, change this to 7, 8, 9. Oops. And then this will be 10. Oh, that's already. No, okay, that's the 10th element, and then I want 11. Cool. So right now, I'm pretty sure that when I run this, it's going to just blow up. And of course it does, because we have an index out of range error. So what am I going to do here when I do add? So if it already contains L, just return. But, okay, so say I get to the end here. So when you add something, when you added the 10th thing, at that point your size is 10, right? So if you go and try to add something there that's like your 10th element, you're not going to be able to do it, right? So what we probably want to do is say that if our size is greater than the underlying length of our data structure, then that's when we should probably grow, right? So what I'm going to do here is I'm going to say if s.full, then s.grow. I think that makes sense. So what does full mean? So func s set full, it's going to return a boolean, and what I guess what that means is that I guess it's full if the size equals the actual length of the underlying data structure. And I said at the beginning we wouldn't use any other functions besides make. I take that back. I'll let you use length. We don't necessarily have to do that. We could actually keep track of the requested size at the beginning, but this is a very easy thing to do anyway. It doesn't really prove a lot. So we'll just say we can use len. So let's do len of s.elements, So if it is full, then we want to grow. So we'll say grow, oops, grow. Again, I'm not going to worry about any sort of error returning or anything like that. If it were more sophisticated, I obviously would. So how are we going to grow here? We need to basically make a new array. We need to copy everything into it, and then we need to reassign that value, right? So we could say, I guess, like bigger equals, and what is that going to be? We want to make, I guess we want to make, it's going to be an array of interfaces again, just like we already have. So what are we going to do size-wise? How about we just double the existing size that we have? That seems like a pretty nice, safe, well, I don't know about safe, but a reasonable algorithm. So we're going to say the length of s.elements times 2. So we'll just double the existing length. Now we need to copy. We have a copy function, but we're not allowed to use that. So let's just say for I equals 0, while I is less than, okay, so it would be s dot size I plus plus. I'm going to say bigger I equals s dot elements I, so that just copies them over. That is my copy step. And then what's the next thing I want to do here? So once they're copied, now I want to say s dot elements equals bigger, and then the original array should just get garbage collected. Cool, so let's see how that works. Cool, that passes. And just to make sure that actually worked, let's do something like expect subject dot contains subject dot, let's just say, let's do all the things we already did, right? So we'll just say is empty 2 equal false. Let's expect subject dot size to equal, I guess it's 11 now, right? And then let's say expect subject dot contains 11 to equal true. Yeah. All right, so we are good, and that concludes our test.